Okay. So last lecture we have proved a non-decreasing sequence. If it is bounded above, then it is attaining its bound. That means have we done theorem as such, or yes na, ak and an given for every k greater than n, ak will be caught between m minus epsilon and m plus epsilon. I think we have done that. So what is the statement of that theorem? And an is a real valued sequence. Condition 1, an is not decreasing, an is bounded above, then an attains its bound. That means limit an as n tends to infinity goes to LUB of that sequence, least upper bound of that sequence, attains its value. It attains its value means it is convergent. It is convergent. It has got a finite value. Okay, as n tends to infinity, you take n higher and higher values, keep doing that, and your sequence stabilizes to some value. We call it as convergent sequence. We did that. And at that time, I think Pranav asked something where I said I will give you a couple of examples next lecture. Pranav, क्या बोले थे आप? कुछ याद है? When we were doing that, and we have proved that 1 plus 1 upon n raised to n as n tends to infinity stabilizes to the number between 2 to 3, and we called that number E. You said if E is addition of rational numbers like 1 upon 1 factorial plus 1 upon 2 factorial plus 1 upon 3 factorial, something like that, plus 1, then why it should be an irrational number? Why it is not a rational number? Because it is summation of rational. And then I said that yes, agreed that it is summation of rational numbers, but number of terms are infinitely many and not finite. So if we are thinking finite and there are rational terms, total number of terms finite, and then they are added, then of course they will produce a rational number. Right? But then when it comes to infinity, things happen little differently, and therefore we should be open to accept. And maybe the reason for some errors or errors in our calculations or some non-pleasant results that if we get eventually, we should say that it is because of that infinity concept which is present in this. Okay, so I will give you 5 examples. Let me check whether you will understand all 5 or not. Yes. By now, how many of you have heard the name L'Hôpital or El Hospital? You must have heard it somewhere, or you must be going through books, solving limit problems. El Hospital or L'Hôpital. Okay, good, half of the students. So maybe that is the very powerful tool to evaluate the limit, especially when the limit is in indeterminate form. Because when the limit is not in the indeterminate form, it is very easy to evaluate because it behaves like our old mathematics, and finding limit is very easy. But if the limit is in indeterminate form, where you are getting 0 upon 0 or infinity upon infinity or 0 raised to infinity, 1 raised to infinity, something like that, infinity minus infinity, some of these kind of indeterminate forms, then L'Hôpital rule or L'Hôpital theorem, which in India or Asian countries is called El Hospital because its spelling is like El Hospital. Actually, that S is not there. It is El Hospital. But it is easy to say El Hospital. These days we are saying hospital, hospital, hospital every day. So El Hospital is easy. And therefore, like that Papu's theorem instead of Papu's theorem. People use it as L hospital rule, and it is very easy. You differentiate numerator, you differentiate denominator, and then try to find out the limit. Limit of this differentiated numerator and denominator and the limit of original is going to be the same. That is what is L'Hopital all about. You are not supposed to use it till we prove it. We will prove it in the class why it works. But there is an example where I am using a L'Hopital to show you not really pleasant result that we are getting. Okay, so let us go back to irregularity. That is the not pleasant वगैरे थोडे शब्द मला सापडत नव्हता. Irregularity because of infinity. Irregularity is because of infinity. Okay, example number 1. S is equal to 1 plus half plus 1/4 plus 1/8 dot dot dot. What is the answer? Answer of this. Find answer. S is equal to अरे केलंय आपण 2. Yes or no?
Yes, sir.
We have done this. This is geometric progression. With first term 1 and common difference 1 minus half. Common difference is half. Therefore, answer is 2. But let me show you another method of doing this answer. What is 2s? 2 plus 1 plus 1/2 plus 1/4 plus 1/8. Yes or no? 2 times s is this much. Out of this s, therefore s is equal to 2. This is okay. Slide and subtract type of quantity only. Same as this actually. But now there is one more method of doing it. Okay, so this is correct. No question about it. Dot 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 means it tends to infinity. Right? But then this method, suppose I say s is equal to 1 plus 2 plus 4 plus 8 plus 16 plus dot 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 up to infinity. Not up to infinity, because up to infinity is a wrong statement. This goes to infinity. And what is 2s? 2 plus 4 plus 8 plus 16 plus dot dot. Yes or no? But this is s minus 1. If you take this one this side, you get s minus 1 is equal to this, right? So 2s is equal to s minus 1. Therefore, s is equal to minus half. S is equal to minus 1. S is equal to minus 1. What is wrong in these calculations? You get s is equal to minus 1 when you are adding 1, 2, 4, 8, 16. बघा समजतंय का?
जर खूप मोठा नंबर असेल तेव्हा त्याला 2 ने मल्टिप्लाय करतो खूप मोठा. जर म्हणजे जेव्हा आपण वरती केलं तर हाफ आणि 1/4 आणि 1/4 आणि 1/8 त्याला 2 ने मल्टिप्लाय केलं ते त्या नंबरला एवढा फरक नका पडत, पण आता खूप पडतो.
एक मिनिट थांब जरा, एक मिनिट. अरे तो श्लोक बोलतोय ते मलाच ऐकायला येत नाही का, तुम्हाला पण येत नाहीये? अरे काहीतरी तू गडगड बोलतोयस एकतर, आणि माईक पण बहुतेक ठीक नाहीये. काय बोलतोयस ते ऐकायलाच येत नाही, कळतच नाही. जरा एकतर स्लो बोल. म्हण बघूया, माझं नाव श्लोक आहे म्हण. अरे माईक टेस्टिंग करायला पाहिजे. म्हण, माझं नाव श्लोक गांधी.
माझं नाव श्लोक गांधी.
हा, हळू, अजून स्लो जरा. माझं नाव श्लोक गांधी.
माझं नाव श्लोक गांधी.
बघ तो कुकाऱ्या मारतो लगेच. थोडा लांब राहा, लांब ठेव. माईक कुठे तुझा? माईक आहे कुठे का? बरं. हा, आणि मग जेव्हा तू बोलशील ना, तेव्हा तुझा स्पीकर बंद कर. स्पीकर बंद कर. स्पीकर केलास? स्पीकर बंद केलास का? अरे माईक,
करतोय सर.
स्पीकर बंद कर आणि माईक चालू कर. केलास? स्पीकर बंदच होत नाहीये. माईक चालू
केला सर.
आणि स्पीकर बंद.
तर स्पीकर बंद आहे.
हा, आता बोल, माझं नाव गांधी आहे.
माझं नाव श्लोक गांधी.
अरे ठीक आहे, तरी बेटर ऐकायला येते जरा. तरी कुकाऱ्या बसताय, त्याचा अर्थ तू माईक काहीतरी चालू आहे तिथं. बरं ठीक आहे. हा, आता तुला जे काय कंटेंट बोलायचं होतं ते हळूहळू बोल.
सर आपण आधी फ्रॅक्शनला 2 ने मल्टिप्लाय करत होतो,
हा.
1 पेक्षा छोट्या फ्रॅक्शनला. त्यामुळे नंबर छोटाच राहत होता. पण आता जेव्हा आपण खूप मोठ्या नंबरला 2 ने मल्टिप्लाय करतो तेव्हा तो अजून खूप मोठा होता.
पण असं काय तुला शिकवलंय का लहान असताना, की नंबर बघायचा आणि मग ठरवायचं मल्टिप्लाय करायचं की नाही? असं शिकवलंय कोणी? नंबर दिसला की आपण कोणालाही मल्टिप्लाय करू शकतो ना. असं कुठे रिअल नंबर मध्ये आपल्याला शिकवलंय की नंबर बघा आणि मग ठरवा मल्टिप्लाय करायचं की नाही करायचं ते? त्यामुळे हे कसं आलं रिझन? ते हाफ आहे म्हणून त्याला केला, 1/4 आहे म्हणून केला. हा, शार्दूल श्री गणेशाय नमः. पुढे काय? सिरीज नॉन कॉन्व्हर्जंट आहे म्हणजे काय? म्हणजे नाही मला समजत आम्हाला. अनकन्व्हर्जंट आहे म्हणजे काय? आपण साधं रिअल नंबरचं ऑपरेशन करतोय, ज्याच्यामध्ये सिंपल मल्टिप्लाय बाय 2 and if you get exactly similar thing you just reduce it, s minus 1, s is equal to, and now the correct आहे म्हणजे तुमचं BR. It is not convergent, it is divergent, it is tending to infinity, therefore you really do not know what happens at infinity, etc. And therefore this is not correct, this is false. Summation of positive numbers, natural numbers, doesn't matter how many you are adding, I mean this s will keep on growing and it will become a big positive number, and if we are reporting it as -1 then definitely it is wrong. But algebraically we cannot find out the mistake. That is the interesting part in it. Algebraically we cannot find out the mistake, and therefore we have to say that the sequence tends to infinity, therefore something wrong is happening. However, in case of fractions or the numbers which are less than 1, that wrong does not happen because they are well behaved. As Shardul is saying, what he is saying is correct. This sequence is well behaved, and this is not well behaved. This is divergent, this is convergent. त्यामुळे ह्या अशा घटना घडत आहेत, पण the reason behind that is infinity. Let me give you another example. I have a total 5 examples. S is equal to, example, S is equal to 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus dot dot dot. What is the answer? सांगा बघूया, चला पॉज करतो मी. Recording pause. Tell me your reason. Okay, so if you do it bracketing like this, then your answer is 0. However, if you do bracketing like this, then you can replace this bracket by s, which is 1 minus s, which gives us 2s is equal to 1. Therefore, s is equal to half. And how do you get answer 1? Because this bracket is 0. Therefore, the answer is 1. So you have answer 0, you have answer half, you have answer 1. मला आता असं वाटायला लागलेलं आहे की यू कॅन गेट एनी आन्सर बिटवीन 0 to 1 बाय डुईंग सम प्री मल्टिप्लिकेशन, पोस्ट मल्टिप्लिकेशन. जरा विचार करा, कॅन वी गेट आन्सर, एनी रियल नंबर कॅन बी आन्सर बिटवीन 0 to 1. Now, why 0 to 1 or actually closed interval 0 to 1? Because we have 0, we have 1. Now, why is this happening is because this is oscillating. S oscillates between 0 to 1. If you consider 3 terms, then it is 1. If you consider 2 terms, then it is 0. If you consider 4 terms, it is 0. If you consider even terms, it is 0. If you consider odd terms, it is 1. Therefore, it oscillates. So it is not convergent, it is not divergent, but it is oscillating sequence. Value of s is, and therefore we get this irregularity. Example number 3. Let x belong to R. Let L be limit. L be the limit. L is equal to limit x raised to n, n tends to infinity. Okay? Now I am free to change the variable. Changing variable n, let n is equal to m plus 1. N tends to infinity. What will happen to m plus 1? M plus 1 tends to infinity, which means m tends to infinity. Correct? So L is equal to limit x raised to m plus 1, m tending to infinity, which is equal to limit x raised to m into x, m tends to infinity, which is equal to limit x raised to m, m tends to infinity into limit x, m tends to infinity, which is equal to x times L. This is x, this is L. Therefore, L is equal to x times L. बरोबर है? What does this imply? This implies either L is equal to 0 or x is equal to 1. Yes or no? But x is equal to 1 is not possible because x is a real number. लक्षात घ्या काय होतंय ते. You get contradiction. X is a real number. And L is equal to 0 is also not true, because if you take x is equal to 2, it is divergent and it will never come to 0 as n tends to infinity. That is precisely what we did in example number 1. Samajhtay ka? So both these statements are not true. Even if we got the result using algebra of limits, irregularity, we need to understand this.
Why can't x be 1?
Why can't x be 1? Because x is said to be a real number. Because x is said to be a real number. Therefore, if you say x is a real number, but finally we say that x is 1, then it does not make any sense. Whatever algebra of limits that we are doing here is perfectly alright.
So, but in algebra of
Come into
limits, when we multiply limits and say that limit of multiplication is multiplication of limits,
Yes.
so that time both the limits were convergent, like they were they were specific real numbers L1 and L2.
Yes.
So, but here, how can we multiply limit x raised to m as m tends to infinity to x?
Yes. No, suppose that is what here. If possible, capital L is equal to limit x raised to n as n tends to infinity. It is given that this limit is L and it is not plus infinity or minus infinity or does not exist. It is given that it is a limit of some function as n tends to infinity. Suppose this is given, then I can always replace. I mean, I am using that rule because both these limits are finite. Both these limits are finite.
Yes, sir.
This is given to be L and this is X. This is independent of M, therefore it is X. Both of them are finite, but then if I use this correctly, if I use the algebra of limits correctly, still the result that I am getting here is not correct. It is irregular because every time L need not be 0, every time X need not be 1 with the given condition. So this is example number 3. Let me show you example number 4. What is example number 4? Limit sin x as x tends to infinity. Which is equal to limit sin y plus pi as y plus pi tends to infinity, limit minus sin y tends to infinity is equal to minus limit sin y tends to infinity. Correct? This implies limit sin x as x tends to infinity is equal to opposite of limit sin x as x tends to infinity, which implies limit sin x as x tends to infinity is equal to 0. Yes or no? But then that is not the case. Limit as x tends to infinity, why should sin x be 0?
सर ते लिमिट डिफाइंडच नाहीये ना.
Huh?
लिमिट ऑफ साइन ऑफ एक्स एज एक्स टेंड्स टू इन्फिनिटी डिफाइंड नाहीये ना.
का नहीं है? It will be between -1 to 1.
तर नाही, पण त्याला 1 पण असू शकतं आणि -1 पण असू शकतं आणि ते 1 लिमिट नसणार ट्रू व्हॅल्यू, त्याच्यामुळे ते डिफाईन नाही असतं.
एक मिनिट, परत तू जोरात बोलायला सुरुवात केली आहे, स्पीकर ऑन ठेवून. माझं नाव श्लोक गांधी असं या स्पीडने बोल.
सर ते -1 पण असू शकतं आणि +1 पण असू शकतं, त्याच्यामुळे मग ते लिमिट डिफाईंडच नाही.
अरे लिमिट डिफाईन नाही असं नाही म्हणणार ना, ते लिमिट असणार आहे आणि ते किती आहे. सो दिस इज अ रॉंग स्टेटमेंट. दिस इज रॉंग. So in spite of the fact that we have done the algebra correctly, we are getting the result wrong. One more version, modification in this, which is limit x tends to infinity sin x is equal to limit sin pi by 2 minus z. X is pi by 2 minus z. So pi by 2 minus z tends to infinity. This implies limit cos z. आणि आता z काय येणार इथे मायनस z. So z tends to मायनस इन्फिनिटी. मी इथे अल्जेब्रा चुकवत नाहीये. As pi by 2 minus z tends to plus infinity, z tends to minus infinity. बरोबर? So algebra is correct. This is one part of the story. आता काय करूया, आता therefore let z is equal to opposite of t असं टाकला तर काय येईल लिमिट cos opposite of t आणि मग z is equal to opposite of t, therefore t tends to infinity is equal to आणि मग cos of opposite of t काय आणि cos t काय, it is same, therefore limit cos t as t tends to infinity. So we started with sine, which we said is equal to 0. Therefore this fellow is also equal to 0. Yes or no? Yes, Mana. Terence Tau has done this. So it is correct. Now if we square both sides and take limit sin square x plus cos square x as x tends to infinity is equal to limit सेम ना, तर sin x आपल्याला माहिती आहे 0, सो sin square x पण 0, cos x माहिती आहे 0, therefore cos square x पण 0, therefore limit 0 x tends to infinity is equal to 0. But we know for sure that this limit is actually equal to 1 because it is sin square x plus cos square x is always 1. So irregularity. अरे समजते काय गंमत आहे. So these irregularities are because of the presence of that infinity, concept of infinity, and therefore we are doing this analysis, we are doing these rigorous proofs, epsilon delta proofs for all the results that we want to use, and that will eventually lead to finding out errors. I mean, we know the errors why they are, because the function that we are discussing is not convergent. If it is convergent, then it is well behaved after analysis, also after taking limits also. But if the function is divergent or oscillating, then it is not well behaved. Okay, so that is what was from Terence Tau. Let us go back to our work. What are we supposed to do now? So we proved limit n tends to infinity. Last lecture we have proved this result. So let us play with that concept now. We have already proved. We have proved. Limit n tends to infinity 1 plus 1 upon n raised to n exists and is finite. We called it equal to E, the fifth irrational number. So we took help of these people, natural numbers here, and our job was easy to compare them because we used binomial theorem for comparison of n sequence and n plus 1 sequence to show that it is increasing function. It was easy because of the binomial theorem. Okay, therefore we took help of nat function, which is a sequence from natural number to real numbers. Now, having done this, now it is our responsibility to check whether, so to check limit x tends to plus infinity to start with 1 plus 1 upon x raised to n is still equal to e or something else. That is what we need to check now, because x is a real number. Now, if x belongs to R, now I am taking it to positive infinity, so x is a positive real number. Let me say that, or even if it is negative, we have to prove a similar statement for x tends to minus infinity also, something like that. So how do we go about it? विचार करा आणि करून मला दाखवा प्रूफ. Correction, this should be raised to x. Okay, so as I have started my recording again, let me tell you what this is. Now, limit x tends to infinity 1 raised to x. Can you tell me how much is this limit? We have done this.
1.
Limit x tends to infinity 1 raised to x is how much?
1.
We said that it is 1. Now, if you try to do that kind of thing over here, if you really substitute this x back over here, and it is plus infinity, therefore 1 upon plus infinity is 0. Therefore, this bracket becomes 1. And to power is infinity, here or here also. If you put n is equal to infinity, it is a too large number in the denominator. That means this limit per se is going to be 0. Therefore, 1 plus 0 is 1 raised to n, where n is tending to infinity. So, is it same as this or different? So, is e equal to 1? But no, this is not equal to 1. We said e is between 2 to 3. Therefore, this is not same as this. Then what is the difference? If it is not same as that, it is not. See, 1 raised to x is not indeterminate form. 1 raised to x is 1. For whatever value of x you put, doesn't matter. But is this 1 raised to x or what? What makes that particular limit exceed 2 and be less than 3 and not equal to 1? It is 1 raised to x eventually as n becomes larger and larger, but then it is not correct. It is a dynamic bracket. It is not the constant bracket. So what we will say this, and maybe while evaluating the limit, we will use this tool also. This is 1 plus small raised to big. This limit is equal to 1 plus a small raised to big is e. So this small is small. It is not 0. That is very, very important. And therefore this bracket is not constant. It is dynamic. It is definitely greater than 1 every time. And therefore it is not converging it to 1, but it is converging it to value which is greater than 1. But that small is not so small, or the small is not so big that it is going beyond 3. The small is small every time you put value of n. So that is making it very, very interesting. Now let me just tell you the application of this. Maybe in 8th standard, whether I have taught you or not, I don't remember. But simple interest, PNR upon 100. Compound interest, amount is equal to P into 1 plus R upon N, number of years, raised to N. Something like that. Rate of interest divided by number of years raised to N. Number of years, or what is frequency of your compounding. Now this is constant. Therefore, if you are compounding after every 1 year, whatever money you will get is definitely going to be less than if you are compounding after 6 months. We have seen that. If you are compounding after 3 months, you will get more money compared to 6 months and 1 year. If you are compounding every month, you will get more money. Keep getting more money. Because here, if I am compounding every 6 months, this factor becomes 2n, 2n. If I am doing it every month, it becomes 12n, 12n. R is fixed. Therefore, we are having this situation. 1 plus this keeps on becoming smaller and smaller. As n, the frequency of compounding becomes bigger and smaller. If you suppose if you do it daily, so this becomes 365. This becomes 365, and so 1 plus small raised to b. And therefore, compound interest, if you apply, the amount increases, and then it becomes stable. Doesn't matter if you compound it after every day or every moment or every minute. The difference in these two values is marginal or practically nothing. And therefore, we don't end up getting compounding every moment. We stop at one particular time. Wherever it is affordable, you stop here. Don't compound beyond this point because it doesn't make any much sense. If this would have been always increasing, if amount would have been always increasing, if you decrease the frequency of compounding and it was divergent, then every person will compound every second, every fraction of second, every moment, every fraction of moment, because he is getting more money, but it never happens like that. It stabilizes. That is why this is increasing sequence, but bounded above. I used to give that example also. Sugarcane juice. There is a machine. You are putting sugarcane in that machine, you are getting something out. First couple of iterations, you get considerable amount of juice out because there is a lot of juice in that. But say for all theoretical reasons, if you keep on doing this, every time you will get one drop of the juice, next time you will get half drop of juice, etc. So will you get infinite liters of juice from couple of sugar canes that you are putting in? Never. It will have a finite limit. How much juice this particular sugar cane can produce has got upper limit. But every time you put it back into the machine, you are going to get something extra. So it is an increasing sequence, but bounded above, and therefore it will converge. So at one particular point, it becomes uneconomical to extract that juice from sugar cane compared to the electricity spent for running that machine. And therefore at that point, he stops for all practical purposes. अरे तुमच्या लक्षात येते का? That is why this limit is very important. It is 1 plus small raised to big is E. Now, but we have proved it for natural numbers. Your job is to prove it for real numbers. Write down complete correct proof. I will write after you. Okay. So the hint is, if we have done something for natural numbers, and if we want to do something for real numbers, let x be caught between two consecutive natural numbers. Consecutiveness is available to natural numbers but not real numbers. Therefore, the first step could be n is less than or equal to x is less than n plus 1. You can always do this. Whatever value of x is given to you, you can always catch it between two consecutive natural numbers. And now you proceed and use sandwich theorem to show that this limit is e, this side is e, and therefore in between also it must be e. Kara काम आता इथून पुढे. That is the starting point. Okay. So n is caught, x is caught between two consecutive natural numbers, and then we start processing these inequalities and check what happens. So 1 upon n plus 1 is less than 1 upon x is less than equal to 1 upon n. 1 plus same. Now, I can raise this to power n. I can raise this to power n plus 1. And I can raise this to power x, because these symbols are uniform. I cannot do power of this as n plus 1, power of this as n, and power of this as x. It is not going to be correct inequality. So I might as well follow the rules of inequality by saying that let me raise this power to n. N is a natural number, less than equal to 1 plus 1 upon x. Let me raise this to x, because this is definitely greater. So greater numbers, greater power is definitely going to be greater than the smaller numbers, smaller power. You cannot say that smaller numbers, greater power is going to be less than greater numbers, smaller power. काय माहिती उलट झालं तर? You never know. That is why it is important. So this equality sign is not there. लक्षात आलं का श्लोक? I can raise this to x and then I can raise this to n plus 1. Now you adjust them so that you will be able to take the limit and get the result. So from here onwards, your algebraic skill is going to be at stake. You do algebra from this onwards, so that afterwards you take limit and use sandwich theorem. लक्षात येतंय का तुमच्या? Okay. So if we want to prove this, further steps are powers n and n plus 1 we have taken, but we want n plus 1 to be here. Therefore we divide by that bracket. We want n and not n plus 1 here. Therefore we multiply by that bracket. Now if we take limit as n tends to infinity, we get e upon 1 for this limit. We get 1 into e for this limit. And therefore limit x tends to infinity 1 plus 1 over x raised to x is going to lie between e and e. Applying sandwich theorem, we get this result where x is a here. So x was tending to plus infinity. So now we need to find out what is the answer for x tending to minus infinity. Okay. So change the variable. X is equal to opposite of y. We get x tending to minus infinity, y tending to plus infinity. So limit y tending to plus infinity, 1 plus 1 upon opposite of y, that is 1 minus actually 1 upon y raised to minus y. Is that correct? Which is equal to limit y tends to plus infinity, y minus 1 upon y raised to minus y, which is equal to limit y tends to plus infinity, y upon y minus 1 raised to y, which is equal to y minus 1 plus 1. So limit y tends to plus infinity, 1 plus 1 over y minus 1. Is that correct? Raised to y minus 1, if I write, that means I am dividing, multiplied by 1 plus 1 over y minus 1. Is that correct? Yes. Now is it in 1 plus small raised to big form? Yes. Y tends to plus infinity, that means y minus 1 also tends to plus infinity. Therefore, I can put the limits back into the place, and therefore this is e, and if y tends to infinity, this is 1, therefore this limit is also e. Okay. समझ गए क्या? This is case 2. Now let us write case 3, not case 3, version 3, limit z tends to 0, 1 plus z raised to 1 upon is also equal to e. Replacing z by 1 upon x, we get the original limit. So just make a mention of this, as z tends to 0, 1 upon x, x tends to plus infinity. And therefore, these limits are e, which is irrational number. No, which is a number, real number. Okay. So, find problem. Limit, or maybe this is theorem. Do this. Limit x tends to 0, e raised to x minus 1 upon x is equal to. Okay, one way of solving this is substitution. Let e raised to x minus 1 is equal to h. Therefore, e raised to x is equal to 1 plus h. Correct? Therefore, x is equal to log 1 plus x, 1 plus h to the base x. If we substitute it in this, what do we get? as extend. Okay, here we have to do this analysis also when we do substitution. As x tends to 0, h tends to 0. Okay? Because e raised to 0 is 1 minus 1, h becomes 0. Okay, so limit h tends to 0, h upon what x, that is log 1 plus h to the base e, इथे x नाही, इथे e, that is logarithm to the natural base is equal to 1 upon h log 1 plus h, limit h tends to 0, which is equal to limit 1 h tends to 0 1 upon limit h tends to 0 log 1 plus h raised to 1 upon h, which is equal to limit h tends to 0 1 is 1 divided by log of limit 1 plus h raised to 1 over h tending to 0. Log and limit are flipped because they are continuous. Therefore, 1 upon log of e to the base e is equal to 1 upon 1 is equal to 1. So this limit is a standard limit. Limit e raised to x minus 1 upon x is a standard limit and its value is 1. We have to use these standard limits at several places, using which we will evaluate complicated limits. Write down, and that is what we have for today's lecture.
सर ती सेकंडला स्टेप एक्सप्लेन करता का लॉग रेज टू ई कसा आला तो
कोणता